Let's talk about bonds, which are a common investment security. Bonds are debt. A corporation or government sells a bond, receiving cash in return. However, they must repay any cash that they receive. So to illustrate this, let's draw two people, person A in blue and person B in green. Now, person A is going to sell a $100 bond to person B, and in return they promise to pay it back in 1 year's time. Person B buys that bond by giving person A $100. Thus, bonds are a form of IOU. Person B lends person A some money, and person A promises to pay it back in the future. But the time value of money says that this is a bad deal for person B. They've lost access to their $100 for an entire year, and by the time they get it back, it's not worth what it was when it was lent. So there must be some incentive for person B to lend the money in the first place. That incentive is that person A will give small payments throughout the loan term. Let's say something like $5 every quarter. So the lender is making some money throughout the loan period, and that's a good incentive. Now, the jargon of bonds is as follows. The face value is the amount of the loan, in this case $100. The maturity is the loan term, in this case 1 year. And finally, there are the incentive payments called coupons, in this case $5 quarterly. So let's work out the present value of the bond. This is a bit tricky, right? There are many different payments being made, all of which occur at different times. To move money through time, we need an interest rate. So let's choose an APR, let's say compounding 1.5% monthly. Often we choose something called the risk-free rate when moving bond payments through time. As usual, let's draw a diagram for our scenario. The compounding periods which occur between payments will be marked in blue. And I'll label them with our rates to remind us that they're compounding events, though these are APR rates, right? Not the term rates. And in green, I'll put the cash payments. Keep in mind that we received the original $100 back at the maturity date. And in this case, that occurs at the 1 year mark. That's why the $100 payment shows up at the end of the timeline. Okay, so to illustrate what we have to compute, the face value needs to be brought all the way back to the present, and the last coupon also needs to be brought back by the entire 12 months. The other coupons are similar, but as they are paid at different times, their present values all have to be computed separately. The third coupon must be brought back 9 months, the second coupon by 6 months, and the first coupon by 3 months. Let's start working out these present values. We are now familiar with the formulas. So we can find that the present value of the face value is $98.51. The fourth coupon uses the same formula, where only the value of S changes. So we can work that out to $4.93. Now, as I've written it, I've computed these payments separately, but instead you can think of them as a single $105 payment which occurs in month 12, and you can compute the present value that way. You get the same answer. Now for coupons 3, 2, and 1, we still have to compute their present values, but the number of months that we need to use for each is different. So for example, we need to use 9 months for coupon 3, 6 months for coupon 2, and 3 months for coupon 1. All right, it's time for a quick concept check. Coupon 4 has a present value of $4.93. So is coupon 3 going to have a higher or lower present value? You should pause and think about this for a second. Okay, so if we plug everything here into a calculator, we get the following results. Notice that as we get closer to the present, the value gets closer to $5. So thus the total present value of the bond is the sum of all of its payments, or $118.32.